clinic and plot the histogram. If your histogram indicates the data is not normally distributed, which average would you use? Okay.
I'm going to share the poll now.
Yeah, I think this poll, 30 seconds should be enough.
Okay, and then poll.
Okay, so let's move on. Let's see the distribution. Okay, so here we see 96% median. So we have, we have some people who think that the mean would work here. So I'm not going to take explanations here. I'm just going to, explain briefly. The answer here is the median. Because if you look at the question, it says it is not normally distributed. When you have data that is not normally distributed, generally speaking, the median is likely to be a multi. What that means is that there are outliers in this data set. And those outliers would pull your mean figure towards them. And that mean figure would not represent most of the population. Like I said, imagine, in a class, imagine in a classroom of, in an undergraduate classroom, you're looking at average wealth. And you're looking at a class that has Bill Gates or Elon Musk, and you are looking at a class that doesn't have any of those people. The average rate, if you calculate the arithmetic mean, it would not give you a good idea of what the average person in that of the wealth of the financial wealth of the average person in that class. So in those kind of situations, a median would be more appropriate. So when data is skewed, when it is not normally distributed, when there are outliers, a median is like it's a better measure.
So I think we can let's just ask a few people if they have questions before we move on. Adio, do you have a question? Let's see if a few hands going up. Akim, you have a question?
Okay, hello, Dr. Motayo. Aside depicting the data in using the normal distribution curve, I wouldn't know if one is given a data set where the graph is not given, how would one know that the data is normally distributed just by checking at probably the mean and the standard deviation that is given? So that's what I want to ask.
Well, thank you. That's an interesting question. I can see people asking that question from the comments also. Like, how do we know if this data set is, if you hadn't told us, how do we know if it's normally distributed or not? So there's a number of techniques. A histogram can give you a fair idea, but quite often the histogram would not be able to resolve whether this is actually uniformly distributed or not. Because, so when we say uniformly distributed, in real life, you have to find a data set that's perfectly uniformly distributed or perfectly, just all over the place. It's somewhere in between. And there are techniques, there are statistical tests that have been developed for testing whether, by and large, this data set is sufficiently uniformly distributed for it to be useful for most of the tests that make an assumption of uniform distribution. But I think those specific tests are beyond the scope of the conversation we're having today. As we progress through the course, in subsequent sessions, you will be exposed to specific tests and specific techniques for assessing your data set to see if it is uniformly distributed and if it will be useful. If it will be useful to use techniques that make the assumption of uniform distribution for such a data set. But for the purpose of this class, I would say that let's just stick to these histograms that we have right now. Of course, there are going to be more sophisticated ways and several other ways for you to make that determination as you go through the courses. Just follow the workshops and follow the other lectures in this series.
So it looks like we already talked about the mode.
Yes, we can move on.
Okay. All right.
So now, a lot of the issues, I mean, most of the conversation we've had earlier, apply to, continuous variables a lot. Of course,